This is the Chapter 8 review activity on concentration and dilution and all that kind of stuff. So when we talk about concentration, concentration is always going to be derived in terms of amount of the substance being dissolved, which is called the solute, in the total amount of a solution. So solution is always solute plus solvent. Solvent is the majority of the substance. Solute is what's being dissolved. So a lot of times we give it in either molarity or millimolar. So molarity is always going to be moles per liter. Millimolar is equal to millimoles per liter. Okay, so you can kind of give it either way, right? Lots of our IV fluids have concentrations of millimolar. And then remember that there are different ways to present composition, and percent composition is always parts per 100, whereas you could say, if you have just a little bit of stuff, you could say parts per million. If you have even less, parts per billion. Okay, let's jump into some problems. And remember, always pause the video, try the problems on your own before you watch me do the solution. So the question here is, what is the molarity? So I already know my molarity formula is going to be moles per liter of 750 milliliters of solution containing 2.25 moles of NaHCO3. Well, right now I already know that's 2.25 moles on top, and then I just need the bottom. And the thing is here, this is given, this volume measurement is not given in liters, it's given in milliliters. And some people can look at this right away and know how many liters that is, but it's okay if you don't. You can just do dimensional analysis. And you could say, okay, I know that there are 1,000 milliliters in 1 liter. So 750 divided by 1,000 is going to give me 0.750 liters. So I'll just go ahead and plug that in. And then 2.25 divided by 7.750 gives me 3. And how many sig figs? Looks like we need to go 3 sig figs molar. The other way that you could say this, it's exactly the same thing as saying 0.003 moles per liter. It's the same exact thing. All right, what is the molarity of a calcium chloride solution prepared by dissolving 145 grams of CaCl2 in a total volume of 2 liters of solution? Here we want molarity, so we're going to use this exact same formula that we used before, moles per liter. But we're given grams per liter. So I'm going to have to convert that grams into moles. So I'm going to start with 145 grams of CaCl2. And I know that there's a relationship between grams and moles of any given substance. And that's called the molar mass. Right? So the molar mass, you go on the periodic table and you go look at calcium. Calcium has a molar mass of 40.08 grams per mole. But that's not all CaCl2 has. It also has 2 atoms of chlorine per molecule, right? So we have to go 2 times the molecular mass of the molar mass of chlorine. So that's 35.45. And then I'm going to add that, multiply and then add, and I should get 110.98 grams per mole. And so all I do is I take this and I plug it in, right? I plug it in up here. And so I have 110.98 grams in 1 mole of CaCl2. And so this will give me moles. So I get 1.3065 moles. And I'm not going to give sig figs until the end. So then I go back to my formula up here and I just plug it in. And I go molarity is equal to moles I have 1.3065 moles per liter, but how many liters do I have? I have 2 liters. So my molarity is equal to 0.653, and you could say moles per liter, or you could just do the big M. Either one is fine. Okay, how many grams of NaCl are needed to prepare 5 liters of a 1.54 millimolar electrolyte replacement solution? So what does this mean? 154 millimolar. That's telling me I have 154 millimoles per liter. Okay. And I'm trying to make 5 liters of our solution. So it doesn't really matter what you start out with. You could start out with the 5 liters. You could start out with 154 millimolar. It doesn't make a difference. I'm going to start out with 5 liters because I want to get to a goal unit of grams, and that's going to be in the numerator. And so 5 liters only has 1 unit, and it's in the numerator. So that's kind of how I decide what to do. Okay, so I have 5 liters. I need my liters to cancel out, so I'm going to have liters on the bottom. What other number am I given that has liters? Well, I know in 1 liter, there's 154 millimoles of my substance. And so, okay, so my liters cancel, right? So then I want to say, I got to get rid of millimoles, and I'm trying to get to grams. So I know that I can use the molar mass relationship to get to grams. So I can say there are 1,000 millimoles in 1 mole. And then I could say in 1 mole, there should be some number of grams of what's my substance? NaCl. So then I have to go in and I actually have to calculate what that molar relationship is. And so if I go look up the molar mass of NaCl, okay, so that should be sodium Na is 58.44 grams per mole, plus my Cl, which we said was 35.45, gives us, no, I'm sorry, I gave you the total. Haha. Okay, Na is 22.89, and then the total there is 58.44 grams per mole. So all I have to do is put in here 58.44. And so let's double check to make sure all of our units canceled. Liters canceled, millimoles canceled, moles cancel. We're left in grams of NaCl, and that's exactly what we wanted, grams of NaCl. Okay, so we do the math and we get 44.9998. Okay, so let's just kind of round that off to, we need 3 sig figs, 45.0 grams of NaCl. So that's just saying how many grams do you need. What would you have to do? You would have to go and weigh out 45 grams, that's a lot, of salt, and then put it in a container and fill that container up to 5 liters. Then you would have 154 millimolar electrolyte solution. What is the concentration in mass by volume of 400 milliliters of solution that has 5 grams of NaCl dissolved in it? So for this one, you just go to that best friend and you go get your percent mass by volume formula, and always, always, always write your formula. Grams of solute divided by milliliters of solution. So where are we told? Oh, and times 100. So what are we told? We have 5 grams. That's our solute, our NaCl. And then we have 400 milliliters times 100, and that should give you 1.25% NaCl. Okay, so that was just plugging into your formula. All right, what is the concentration in parts per million of a solution that contains 0.155 grams of glucose in 125 milliliters of solution. If I see ppm, I just go and get that formula. ppm, parts per million, equal our grams of solute over milliliters solution. And instead of being times 100, it's going to be times 1,000,000. Okay, so then all we do is plug it in, and we say parts per million is equal to, we'll have 0.155 grams, that's our solute, right, of glucose, divided by total milliliters of solution. They told us that was 125. We're going to multiply that times 1,000,000, and we get 1,240 parts per million. So just make sure you have the units right and that you're multiplying by the right number. So 1,000,000, 1,billion, 100, whatever it may be. All right, how many grams of glucose are present in 750 milliliters of a 5% mass by volume glucose solution? So this is using exactly the same formula we had before. Percent mass by volume is equal to our grams of solute over our milliliters solution times 100. So now all I'm going to do is I'm going to go plug things in. This is my percent mass by volume. Here's my milliliters, and then my unknown is going to be my grams of solute. So I'm going to have 5.0% is equal to, I don't know, some number of grams of solute, right? I don't know what that is, over 750 milliliters of solution times 100. And you could put that as, they're told it's glucose, right? So now, what's my variable? Here's my variable right here. This is what I'm trying to find. So what I do is I look at what's being done to the unknown, the variable, and then I do the opposite to it. And when I do to one side, I have to do to the other. So I look and I say, okay, over here, I'm multiplying by 100. So what I need to do is divide by 100 so that my hundreds cancel out, right? And then I'm dividing by 750, so I need to multiply by 750. So my 750 cancels out. But over here, I have to do exactly the same thing, 750 over 100. And so now my X grams of glucose are equal to, and what you should get is 37.5, but we only got 2 sig figs, so it's really 38 grams. Okay. How could you prepare a 0.9% mass by volume NaCl solution using 1 liter of water? So again, I'm going to start out with the formula that I know, this mass by volume percent. And as many times as you write it, it's fine. Just make sure you write your formula and then you plug in wherever your numbers should go. Okay, so I want to make a 0.90% mass by volume solution using 1 liter of water. But look at this. I'm in milliliters and liters. Can I do that? No, I can't. Where's my eraser? Here we go. So what I'm going to do is I'm going to take 1 liter and I'm going to convert it. And I'm going to say, okay, in 1 liter, I have 1,000 milliliters. So that's 1,000 milliliters. And if you did that in your head, that's cool. Times 100. So this is my unknown right there. So I do the exact same thing that I did before, where if I'm multiplying by 100, I'm going to divide by 100. If I'm dividing by 1,000, I'm going to multiply by 1,000. So these cancel and these cancel, and what I did to one side, I have to do to the other. Okay, and so what is X? What you should get for X is you should get 9 grams. So how would you prepare it? You would weigh out, like you could write this out on the side. You would add 9 grams of NaCl, right, to enough water to make 1 liter. Like you wouldn't say I'm going to add it to 1 liter because you're putting in 9 grams of salt, and that actually takes up space, right? So it would change your volume. Okay, a healthy concentration of cholesterol in the body is below 240 milligrams per deciliter. A deciliter is 100 milliliters. So what we say is 1 deciliter is equal to 100 milliliters. So what would this concentration be in percent mass by volume? Well, jot down your formula. Percent mass by volume, grams of solute over milliliter solution times 100, and that will give you what you're looking for. But here's the thing. I'm going to go and plug this stuff in, okay? So I'm told that's 240 milligrams. I can't plug in milligrams. I need grams. So I'm going to go ahead and I'm going to do a conversion. So I have 240 milligrams, and this is actually 240 milligrams per deciliter, right? And I need to get it into what? Grams per milliliter, okay? So I'm actually going to have to change both units. So let's tackle the milligrams first. I want to get rid of milligrams and I want to go to grams. So I know I have 1,000 milligrams in 1 gram. So that tells me my milligrams cancel. I'm left in grams, and that's what I want. I want to be in grams. And then deciliters, I gotta get rid of deciliters. So I have this equivalence over here. 1 deciliter is equal to 100 milliliters. And so my deciliters cancel, and I'm left in grams per milliliter. And that's exactly what I want. So put that into your calculator, and what you should get is 0.0024 grams per milliliter. So I plug that into my formula up here, and I go 0.0024 grams per milliliter times 100. What you should get is 0.24% mass by volume. So it's not very much cholesterol, which is a good thing. Calculate the molarity and millimoles per liter of 800 milliliters of solution with 5 grams of NaCl dissolved in it. Okay, the first thing that I want to think about, right? If I'm going to molarity or millimolar, what I need to do is I need to get my volume out of milliliters and into liters. And so I know 800 milliliters, right? If I say that's 1,000 milliliters in 1 liter, that would give me 0.8 liters. Okay, so that's a good little piece to know. Now, what I want to do is I want to get to molarity, and I know my molarity is our moles per liter, right? So I got 5.00, I guess I should put my formula, y'all, right? So my molarity is equal to moles per liter, right? So my number of moles, I'm not in moles, I'm in grams. So I got to get out of grams. So I'm going to go 5.00 grams of NaCl, do dimensional analysis. And remember, we did up in number 3, we got the molar mass of sodium chloride, and that was 58.44 grams NaCl in 1 mole NaCl, right? So now we're in moles. And so if we do that math, let's do it real quick. We got 5 divided by 58.44, and we're going to get 0.085558, okay? And that's in moles because we canceled out our grams, so now we have our moles, 0.085558 moles per liter, and we calculated we had 0.8 liters. So if we take that and we divide by 0.08, what we get is 1.069. How many sig figs? We got 3, so 7. And that is in molar, but they actually also asked us for millimolar. So all you would have to do is a little conversion here. And what you're going to do is you're going to say, okay, if I have 1.07 moles per liter, that's what molarity is telling me, that I have that. And I want to go to millimolar. I know in 1 mole, I have 1,000 millimoles. And so I have that number times 1,000 would give me 1,070, and this would be millimoles. I'm running out of room per liter, right? So it just depends on what you're asked for and what you need to give. And I did that wrong. I gave y'all, I put an extra 0 in there. There's no 0 there. Okay, so then that will change these. Always double check. I was like, that's really a big molarity. Okay, so now 0.08555 divided by 0.8 gives me 0.107 molar, okay? And then 0.107 molar times 1,000 is going to give me, right, times, 107 molar. It's still pretty big, but okay. A 40 millimolar KCl solution is used to treat patients with low potassium levels. How many moles of KCl are present in 2 liters of this solution? How many grams are present? All you're doing here is being asked to do dimensional analysis. That's it. So what are we starting out with? Let's see. We have a 40 millimolar, and sometimes I like to go in, circle what I have, right? And I know that I have 2 liters of the solution. And my goal is how many moles of KCl and then how many grams of KCl. So it's like a 2-parter. So I'm going to start with 2 liters, right? Okay. And so I know I have 40 millimolar. What is millimolar? Millimolar is equal to millimoles per liter. So I can use that at the bottom. And I can say, I know I have a 40 millimolar solution, right? So now I've canceled out my liters. I'm in millimolar, but I don't want to be in millimolar. I want to be in moles. And so now I'm going to say there are 1,000 millimoles in 1 mole. And so if I do the math on that one, that should give me 0.08 moles of KCl. So that answers this first part. So like this is number 1. This is my answer to number 1. Then I want to go from moles to grams. Okay, that's another dimensional analysis, right? So I want to go in 1 mole of KCl. Now I got to go get my KCl molar mass. So K, potassium is 39.10 plus Cl, which was 35.45, and that together gives me 74.55 grams KCl. And so I should get something that is 6.0 grams KCl. So this is really my number 2. That's my number 2 question. That's my number 2 answer. Right? So just make sure that the work you're doing is answering the question that's being asked. All right, the optimal value for CO2 dissolved in adult blood is 27 millimolar. Calculate the number of moles present in CO2 in the blood if an adult has a volume of 4.8 liters. Okay, cool. So we got 4.8 liters, 27 millimole, and my goal is calculate number of moles of CO2. Okay, so what do we want to start with? I'm trying to go to just moles, just one, so I'm going to pick the 4.8. You could have picked any one, though. It works no matter what you do. Okay, so 4.8 times I have 27 millimoles per 1 liter. That's what millimoles means, right? And then I want to know how many moles, so then I got to convert out of millimoles. I know there are 1,000 millimoles in 1 mole. And so what that should give me is, how many sig figs? 2, so that rounds to 0.13 moles of CO2. What is the concentration in percent mass by volume of solution containing 0.3 grams of glucose and 60 milliliters of solution? So our percent mass by volume is our grams solute over milliliters of solution times 100. Now I'm just going to go ahead and plug my values in, and I know I have 0.30 grams of glucose per 60 milliliters of solution times 100, and that should give me a 0.5% glucose. The next one is a percent volume by volume. We hadn't done one of these yet. And so I'm going to write down my formula. I haven't even finished reading the question. I can write down my formula. Milliliters of solute over milliliters of solution times 100. So we're looking for the concentration in percent volume by volume prepared by mixing 50 milliliters of ethanol with 450 milliliters of distilled water. Be careful here. What we're trying to do is we're trying to get the whole thing. So all the stuff put together, solution is solute and solvent. So when I plug this in, my solute is the one that's in lower amount. So that's my ethanol. And then my solution should be my ethanol plus my water. So it'd be 50 milliliters plus 450 milliliters, okay, times 100. And so make sure you do what's down here in your calculator in parentheses, or you might get that messed up. So what you should get is something that is 10% ethanol, volume by volume. Okay, what is the concentration in mass by mass of a solution prepared by mixing 10 grams KCl with 100 grams of distilled water? So I'm going to write my formula. Percent mass by volume is going to be grams solute over milliliters solution times 100. So I'm going to go ahead and plug in what I know. I know I have 10.0 grams KCl, and I know that's the solute. And that's supposed to be mass by mass. Ho, 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 mass by mass. Right? Okay. And so I'm going to put the one that is lower, in the lower amount, that's the KCl, is the solute. So that one goes on the top. And then our grams of solution. Be careful with this. Our grams of solution are both the solute and the solvent. So it'd be 10 grams plus 100 grams of water times 100. Make sure you put that in parentheses. And what you should get is 9.09% KCl. How many grams of insulin are present in 26 grams of a 0.45% mass by mass solution? Okay, so I'm going to use my formula. Percent mass by mass is going to give me grams solute, grams solution times 100. Okay, so now I just need to plug into this formula. So when I plug into the formula, this percent goes here. 0.450%. Then I have, this is taking up too much room. Let's scooch that over. Give us some more room. We're going to do it over here. Okay. So our grams of solute, we're going to do as 26.0 grams. Oh, no. That is our solution, right? Whoa. We got 26.0 grams solution times 100. And so our unknown is our grams of insulin. So we have X grams of insulin. And our insulin would be our solute. And the solution is all of this information that they gave us right there. Okay, so to get my variable alone, whatever's being done to it, I do the opposite. So here we're going to do 26 over 100. And so when you solve, you get X grams of insulin. And so your grams of insulin should be 0.117 grams. Okay. How many grams of NaCl must be combined with water to prepare 500 milliliters of a 0.9% mass by volume physiological saline solution? Okay. So we're going to use our formula, and our formula is our mass by volume. Grams of solute over milliliters of solution times 100. Okay, so now I know how much I want. This is my solution is 500 milliliters, and it should be a 0.9%. So I'm going to plug in the 0.9% where the percentage goes is equal to, and I don't know how many grams of NaCl. It's my X. And I'm going to prepare 500 milliliters of the solution times 100. Just do exactly what we've done before. If we multiply, we divide. If we divide, we multiply. If you have a different way that you do it, cross multiplying, stuff like that, that all works, and you can do that. So we have X grams of NaCl, which are going to equal to 4.5 grams. Okay. What is the concentration in parts per million in a solution containing 0.3 milligrams of fluoride and 60 milliliters of tap water? What is the concentration? Oh, in parts per billion. Okay, so we're looking for concentration in parts per million and parts per billion. So let's go ahead and do this in parts per million. Parts per million is going to be our grams of solute over milliliters of solution, and then 1,000,000 times. Oof. Okay, so we're going to plug that in. Our grams of solute, ooh, we're in milligrams. We got to convert that. We got to say, okay, in 0.30 milligrams, I know there are 1,000 milligrams in 1 gram. So that gives me 3 zeros and a 3 grams. So we're going to plug that in. We got 0.0003 grams of our fluoride in 60 milliliters of tap water. Okay. And then we're going to do that times our million, and we're going to get 5 parts per million. And then if you did exactly the same thing, and all we did was multiply by 1 billion, then what would your answer be? It would be 5,000 parts per billion. It's the parts per billion formula is exactly the same, except it's 1 billion instead of 1 million. That's it. Okay, last one. Blood sugar is measured in a unit called milligram percent, which is milligram per deciliter. Normal values for blood sugar are below 110 milligram percent. What is this value in percent mass by volume? Okay, so we know mass by volume is our grams per milliliter, right? And we know from number 8 above that 1 deciliter is equal to 100 milliliters. So if we know that we have 110 milligram percent, that's just like saying we have 110 milligrams per deciliter. Same thing, because they just told us that. Milligram percent is milligram per deciliter. Now I'm going to take this and I'm going to do dimensional analysis to get to the units that I want, because the units that I want, right, we're trying to calculate percent mass by volume. Well, what do I want? I want grams of solute over milliliters of solution times 100. So I want to end up in grams per milliliter. So I'm going to have to convert both of my units. So let's go do deciliters first. So I know in 1 deciliter, I have 100 milliliters, and that is the unit I want. So that's good. So then, because my deciliters canceled, I'm ending in milligrams per milliliter. But that's not quite what I want. I really want grams per milliliter. So I'm going to come back here and I'm going to convert. I'm going to say, okay, there are 1,000 milligrams in 1 gram. And then I should be able to just do my math, and I should get 0.0011 grams. And what are we doing this in? With sugar, blood sugar, right? Per milliliter times 100. And so all I did was plug in, right? This is my grams of solute are right there. My milliliters of solution are right there. So, and then I just multiply by 100. Okay, so let me kind of erase those things. Okay, so now what do I get when I do this? And I get 0.11% mass by volume. Next video will be on dilutions.